Hello all, I'm Harita Stacey. My case study in probability and statistics is about statistical hypothesis testing for CO4, which is to apply the concept of testing of hypothesis for small and large samples. Statistical hypothesis testing means it is the method that determines if data supports a hypothesis about a population, in which we have to follow few steps. Those steps are firstly, we have to formulate the hypothesis H naught and H1, which means null hypothesis and alternate hypothesis. Then next, collect data from the population and then collect the test statistics from data and compare the two sample data and then decide which one to accept and which one to reject. And then lastly, conclude and sum. In statistical hypothesis testing, we have three types. They are right-tailed, left-tailed, and two-tailed. We have a lot of applications based on the statistical hypothesis in real world. As in engineering, we have quality control and reliability testing, process improvement and optimization, structural engineering and material testing, control system engineering, environmental engineering, pollution control, which means energy engineering and energy design and solution. I guess we have a lot of application in engineering. Uh, the example for this topic based on the scenario-based problem with solution. Firstly, let us have go through this example. From the data available, it is observed that 400 out of 850 customers purchased the groceries. Can we say that most of the customers are moving towards online shopping even for groceries? This is the problem statement, and the solution is um, we have to first look for the type of test we have in this question. For us, we have test number one, which is a test of significance between sample proportion and population, which means Z test. In this question, we are given small p, which is like sample proportion, which is nothing but for 850. We have to calculate the large p, which is nothing but 400 divided by 850, we can get 0.47. And then we have to fix some statement for H naught. Since the probability of moving towards online shopping, even for groceries, which means at least 50% should do online shopping. So let us take capital P as greater than zero point 0.5. And in H naught, let's take 0.5, which means P is lesser than zero point 0.5, which is left tailed and N is equal to 850. According to this statement, yeah, level of significance is equal to 5%. Like it is about assumption we are giving. And N is greater than or equal to 30, hence we go for a Z test. So step one is we have to calculate the Z value. So Z value formula is small p minus capital P divided by root of PQ by N. Substituting those values, we can get Z value as minus 1.7. And at step two, I have to check the table at 50 percentage level of significance from the Z table. It is calculated. The Z alpha value is like minus 1.674. It is left tail, right? So the calculated value is somewhat lesser than the value we are obtained from the table. So from this, we can conclude we are rejecting null hypothesis, which means H naught, and we are accepting H1, that is alternative hypothesis. This means we can validate significantly that most of the customers are not moving towards online shopping even for groceries. Okay, let's move on to the next question. So, from the following record of number of accidents took place during the various days of the weeks, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday, can we conclude that the accidents are independent of the day of the week? So for this question, first of all, let's understand the question. Here, the weeks are given, the days are given for a week, and Corresponding days have following number of accidents that takes place on that day. From this, we have to conclude that we have to find whether the accidents are independent of the day of the week or not. So let's give an assumption of H0 as accidents are independent of the day, and then H1 is not independent. So from this representation, the sample and observed data is proportion. Hence, this problem can be categorized as multiple proportion program, which is nothing but a chi-square test. In chi-square test, for analyzing the characters, the respective formulas are observed minus expected divided by expected. And before that, we have to take we have to assume that the level of significance, that is alpha, is equal to 5%. It is not given in the question. We have to give our assumption. Based on this, we have to proceed. Step one is to calculate the expected values and chi-square values using the formula as below in the table. So in this table, observed value is in one column, and the expected value is nothing but the average of those observed values. And then chi-square is calculated based on the following: observed minus expected, the whole square divided by expected. Calculating those following values, and at last we have to give summation. After calculating this summation, step two is to use chi-square table for 5% level of significance and get chi-square value from the table. From this, we can calculate like critical value at 5% is nothing from the table, chi-square table. It is given like 3.84. One is the expected value. Comparing the calculated value and the expected value, chi-square value of 60.05 is much larger than the critical value. So here null hypothesis is rejected. It means reject the null hypothesis H1 and accept the alternate hypothesis, which means with the given data, we can conclude significantly that accidents are not independent of the day of the week. It might not look realistic, but with the given data, it is concluding like that. This is the graphical representation of the above sum given. That's all. Thank you.